Hi, welcome to the fifth lesson video for number systems. In this video, we are going to look at operations on real numbers. So first, we'll just quickly review the properties for rational numbers and see if they apply for irrational numbers. You've learned in smaller classes about commutative property, associative property, distributive property, and closure property. So by commutative property, we mean if you add a plus b, is that the same as b plus a? Similarly for subtraction, multiplication, and division. So is 2 into 3 the same as 3 into 2? Is 2 divided by 3 the same as 3 divided by 2? You have examined all these questions last year, and we know that commutative property is true for addition and multiplication. We also have associative property for addition and multiplication. So by associative property you mean is 2 into 3 into 5 the same as 2 into 3 times 5. So this is associative property for multiplication. Similarly, if you replace the multiplication signs by addition signs, you get the associative property for addition. So we have seen in smaller classes that associative property is true for addition and multiplication of rational numbers. You also know about distributive property. So if you get a calculation like 3 into 6 plus 5, that is the same as 3 into 6 plus 3 into 5. This is distributive property of multiplication over addition. So you know that distributive property also holds for rational numbers. And finally, you come to closure property. By closure property, you mean if you add two rational numbers like 1 by 3 plus 6 by 7, do you get another rational number? So you know that closure property is true for addition, multiplication, subtraction, and for division it is true, but with a condition: you cannot divide by 0. All non-zero rational numbers are closed under division also. So that's closure property for rational numbers. Now when you come to irrational numbers, if you just take a few examples and check for yourself, you can find that commutative property is true for addition and multiplication for irrational numbers also. So for example, root 2 plus root 3 is the same as root 3 plus root 2. And you can also write for multiplication, if you use the same example, root 2 into root 3 is the same as root 3 into root 2. So that's commutative property for multiplication. So you can see that commutative property is true for addition and multiplication even for irrational numbers. And if you take similar examples, you can also see that associative property is true for addition and multiplication of irrational numbers. So for example, root 2 plus root 3 plus root 5 is the same as root 2 plus root 3 plus root 5. So this is associative property for addition. Similarly, you can find that associative property is also true for multiplication of irrational numbers. And distributive property is also true for irrational numbers. You can take examples and check it yourself. So the big difference comes in closure property. So for closure property of irrational numbers, you can say that irrational numbers are not closed under addition, subtraction, multiplication, or division. Let's take a couple of examples to see why they are not closed. So let's try adding two irrational numbers, root 2 and minus root 2. So if you add root 2 and minus root 2, you will get 0, which is not an irrational number. So 0 is a rational number. So you can say that irrational numbers are not closed under addition. Similarly, if you take multiplication, if you take root 2 into root 2, you see that you will get 2, which is a rational number. So it is not closed under multiplication. Similarly, you can check for subtraction and division. So that's a major difference in the properties of rational and irrational numbers. Irrational numbers do not have closure property. Now let's examine some operations on real numbers. In this section, we are going to do the addition, multiplication, subtraction, and division operations on two numbers in which one number is a rational number and the other is irrational. So here, if you look at the question, you need to check if 7 root 5, 7 by root 5, root 2 plus 21, and pi minus 2 are rational or irrational. So in each case, for example, 7 root 5, you see that a rational number is multiplied with an irrational number. Similarly for the others, 7 by root 5, you have one rational number and an irrational number. Root 2 plus 21, you are adding an irrational number with a rational number. Similarly for pi minus 2. Now without actually performing these calculations, you can see that the result is going to be irrational. If you just use your logic, you'll find out that the result of these calculations is going to be an irrational number. Let's try to see why. So the decimal expansion of root 5 is 2.236 and so on. It's a non-terminating, non-recurring decimal. Now if you multiply this with 7, so if you do 7 into 2.236 etc. So 7 root 5 is equal to 7 times this number. It's obvious that the answer that you get is going to be a non-terminating, non-recurring decimal. So it's going to be an irrational number because you're multiplying 7 with a decimal which has a non-terminating, non-recurring expansion. Similarly, if you do 7 by root 5, that's the same as 7 by root 5 into root 5 divided by root 5, which is 7 root 5 divided by 5, which is 1.4 times root 5. So again you are multiplying 1.4 with an irrational number. So in the result, the decimal expansion is going to be non-terminating and non-recurring. So this is going to be again an irrational number. If you add root 2 and 21, you are adding a number which goes 1.414 and so on with 21. So you are going to get 22.414 and so on. So this is again an irrational number because the decimal part is going to be non-terminating, non-recurring. You can use a similar reasoning for pi minus 2. So what we observe from these 4 examples is that if you add or subtract or multiply or divide a rational number and an irrational number, the result is going to be irrational. The only exception is if you multiply by 0. So if you're multiplying 0 with an irrational number like root 5, the answer is going to be 0, which is rational. And if you divide 0 with an irrational number like root 2, the answer is going to be 0, which is rational. So that's the only exception to this rule. If you multiply or add or subtract or divide a rational number that is a non-zero rational number and an irrational number, the result is going to be irrational. Now let's move to the case when we are performing operations on two irrational numbers. If you are adding two irrational numbers or subtracting or multiplying two irrational numbers, what do you get as a result? Let's take some examples. If you are adding two irrational numbers like root 2 and root 3, this is going to be irrational. But at the same time, if you are adding root 2 and minus root 2, both of which are irrational, you will get 0, which is rational. If you check for multiplication, root 2 into root 3 is root 6, which is irrational. But root 6 into root 6 is 6, which is rational. Similarly, you can do this for division and subtraction, and you can get, depending on the choice of the numbers, you can get either an irrational number or a rational number as your answer. So let's summarize what we have learned so far through these examples. So if you go back in the video and look at all the examples we have worked out for operations on real numbers, you can see that these three statements summarize what we have done so far. So instead of learning these rules by heart, it's better to just think about the situation logically and decide if the answer is going to be rational or irrational. And with that, we've come to the end of this video. Thanks a lot for watching.